Hi everyone, welcome to Go Classes. So in the last lecture we have already seen what is a flip-flop, how they work. Okay. In this lecture we will see some timing issues in the flip-flop. For example, hold time, setup time. These two things, these two concepts we will see. These are the timing issues with the flip-flops. Okay. So these we will discuss. And so we already know what is a flip-flop, what is a latch, all these things we already know. What is edge triggering? Okay. So flip-flops are normally, usually flip-flops are edge triggered, latches are level triggered. So these concepts we already know. And now we have already seen what is a synchronous circuit. So synchronous sequential circuit, what it means, synchronous means synchronized with the clock. Okay, so remember the definition. Let's see the definition of synchronous. So what is the synchronous sequential circuit? Synchronous sequence circuit means basically any sequential circuit which is synchronized by a common clock. So there is a common clock. Okay, I can say there is a system clock, and that same system clock is basically applied to all the flip flops. So you have, let us assume you have three flip flop 1, flip flop 2, and flip flop 3. So you can notice synchronous sequential circuit means that all the sequential elements, okay, for example all the flip flop latch, all the things, all these things, okay, I can say, so basically all the flip flops actually. Okay, so if you have any flip flop in your circuit, then these flip flops are basically synchronized with the common clock. So this is a common clock, I can say this is a common clock, and this same clock is applied to all the flip flops, to all the memory elements. This same clock is applied. So you can notice all these flip flops, all these memory elements, all these sequential elements, they are basically synchronized, okay, by the common clock. Okay, so this common clock, this will decide their operation. Okay, so this is a simple definition of synchronous sequential circuit. Means a sequential circuit in which every, okay, all the flip flops, they are synchronized with the common clock. Okay, so this is the concept. Now now let's see some issues. What we are going to see now, we are going to see some timing issues about these flip-flops. Okay, so some timing issues, particularly we will study what is hold time and what is setup time. Okay, so these two concepts we are going to see. Okay, we will see what are these concepts and why we need these concepts. Basically these things we will see, don't worry. But before that, we already know that flip-flops are usually edge triggered. Okay, so you already know that all the flip-flop can be either level triggered or edge triggered, but usually, okay, the flip-flops are basically edge triggered. So these concepts, the whole time, setup time, these concepts we are going to see for edge triggered flip-flops. Okay, so we are going to study these concepts we are going to study for edge triggered flip-flops. Okay, so let's study what are these concepts. So these are the timing issues, I can say. Okay, so remember these are the timing issues. This will be clear. Okay, what do I mean by timing issues? This will be clear when we study hold time, setup time. Okay, now let us see what is this hold time and setup time. See, you can notice one thing that let's take one example here. Okay, so for example, consider this hold time, setup time. Let's understand what are these times. Okay, so what are these timing issues? Now you can notice, just consider this flip flop. So consider this D flip flop. You can notice in this D flip flop we have edge triggered. So this arrow means basically positive edge triggered. This flip flop, this D flip flop is basically positive edge triggered. Okay, so this arrow means basically this flip flop is positive edge triggered. Means when the positive edge will come. Okay, when the clock, when the rising edge, on the rising edge, the I can say on the rising edge of the clock, this flip flop will work. Okay, so in the remaining time, okay, for example when your clock is 1, when your clock is 0, okay, or when your clock is falling, in this duration your this flip flop will not work. And only during this period, only during this rising edge, only during this positive edge, this is called positive edge or rising edge, during this period this flip flop will work. Okay, now let us see what is the issue here. So the issue is this: just assume that you are applying the, okay, let us assume this is your clock. Okay, so let us assume this is the clock signal. Now in this clock signal you can notice that, so this is the rising edge, this is the rising edge, this is the rising edge, and this is our clock signal. And let us assume we have the, okay, signal D. So the signal, that the input signal basically, okay, the input signal D. So let us assume that input signal D is like this. Okay, So here you can notice the input signal D is like this. Let us assume. Okay, so the input signal is like this. Now you can notice one thing, that very simple, what will be the output signal? So initially I don't know what is the output signal. So initially let us assume that output signal can be anything. I don't care about it. Okay, so remember, this means that initially Q can be anything. Initially Q can be 0 or 1, I don't care. Let us assume that initially Q is 0. Okay, let us assume that initially the output was 0. Now you can notice this is the rising edge of the clock. So during the rising edge of the clock, this flip-flop will work, and I can say that Q will be equal to D. So during this rising edge, I can say that Q will be equal to D, and because at this point of time, you can notice D value is 0. At this point of time, you can notice. So that is the reason this Q will be 0 till the next rising edge. Okay. So till the next rising edge, this value will be 0. Now you can notice there is a problem here. Okay, so here there was no problem, because during this rising edge, you can notice already we know that value of D is 0. Okay, during this rising edge, you can notice this value of D was already 0. Okay, but you can notice during this rising edge there is a problem. What is the problem? When this clock is going from 0 to 1, basically when during this positive edge, you can notice the D value is going from 1 to 0. Now here there is a problem, here there is an ambiguity, here there is a confusion. What is the confusion? We don't know whether, okay, whether we don't know whether this flip flop is going to consider the value 0 or value 1. We don't know. Yes or no? Is this this is ambiguity or no? Okay, we don't know. Correct? Yes or no? So you can notice here the clock is going from 0 to 1, and at the same time, okay, the D input is also going from 1 to 0. So there is a problem. What is the problem? We don't know basically what this flip flop will do. Okay, so this flip flop will do what? Okay, we don't know, because you can notice the transition, the age, the, I can say the clock age is coming at the same time when the input is changing. Okay, when the input D is changing. So I don't know what to do here. I don't know what this flip-flop is going to consider, whether this flip-flop will consider 1 or whether this flip-flop will consider 0. I don't know. Okay, so this type of issue. Okay, so there is an issue here. Okay, and you can notice this issue. So you can, okay, just let me mark it here. So you can notice this issue. Okay, so so this issue, let me write it like this. Okay, now you can notice this issue is known as, I can say, okay, this issue is known as setup, basically setup violation. Setup violation. Let me explain what is this setup violation. Let me explain. This is like this. Okay, let us assume that you want this. Okay, let us assume that this is your, okay, I don't know what is my input D, but let us assume that I want my output to change from 0 to 1. Let's assume. Okay, so let me assume that I want my output to change. Okay, at this rising edge, I want my output to change from 0 to 1. Let's assume I want this is what I want. Let us assume. Okay, so I am assuming that I want my output to change from 0 to 1. Okay, now if I want my output to change from 0 to 1 at this rising edge, then what I need to do? So you can notice in this flip-flop, okay, you can notice that right now my output is 0, but what I want this output to change from 0 to 1 when the next rising edge comes. Okay, when the next rising edge will come, I want my output to change from 0 to 1. So what I need to do? I need to apply the input D equal to 1. Okay, so at the input, I need to apply 1. Now, when should I apply 1? This is the question. The question is, when should I apply this input 1? Okay, so this is the question that I want to ask. Okay, so you can notice this positive edge is coming here. Okay, at this point of time, this positive edge is coming. So if I want my input, if I want my input, if I want my output to become 1, okay, on this rising edge, what I need to do? I need to provide a input 1. Okay, this input signal I should provide 1. Okay, and this input signal I should provide a little bit earlier than this edge comes. Okay, a little bit earlier, I can say. So this D equal to 1 I should definitely provide, okay, sometime before this rising edge comes. Okay, I don't like, okay, you can provide it here also, no problem, but I am saying that you cannot provide like this. Okay, you cannot do like this. You cannot do like this. See, if you do like this, then there is a problem. Again, there is a problem, because we don't know what this flip-flop will behave. Okay, the behavior of this flip-flop is again unpredictable, because what you are doing during this rising edge, you are changing the input. Okay, so during this rising edge, if you are changing the input, we don't know what this flip-flop is going to behave, because we don't know whether this flip-flop is going to consider the value 0 or whether it will consider the value 1. So you can't apply this input D, you can't change this input D at this point of time. Okay, during this rising edge you can't change this input. So what I need to do, I need to do something else. Okay, what I need to do, I need to basically, okay, provide this input. I need to change this input, I need to provide this 1, because I want my output to be 1. So I need to provide this input, okay, sometime before this rising edge. Okay, sometime before this rising edge. This is the, okay, now there is one more point. Okay, so I need to provide this input sometime before the rising edge, and also I need to keep this input, I need to keep this D equal to 1 sometime after this rising edge. Okay, because remember, if I don't do this, okay, just assume what will happen. Okay, let us assume that, okay, let's assume that you are providing this input D, you are changing this input D, you are making this input D equal to 1 sometime before the rising edge. That is fine, that is fine. But let us assume you are doing like this, let us assume you are doing like this. Then in this situation, again there is a problem, again there is a problem. What is the problem? Again we don't know, because during the rising edge you are changing the input. Okay, during this, at the same time, when this age is going from 0 to 1, at the same time you are changing your input. So again we don't know what this flip-flop will is going to behave. We don't know whether this flip-flop will consider 0 or 1. Okay, so this is the problem again. So what I need to do, I need to keep, I need, okay, after this rising age, okay, I need to keep this D equal to 1. Okay, so this D input I need to keep stable sometime after this rising age also. Okay, so sometime, okay, after this rising age also, something like this, something like this. Now you can notice again, during this rising age, already this input D is 0 for some time. And okay, and again remember, after this rising age, again I need to keep this input D stable. I need to keep this D input stable for some time. Okay, so you can notice this will happen. Now you can notice during this rising age, the input D was already 0 for some time. For some time, you can notice for some time the input D was already 0, and you can notice after this rising age, for some time input D is already 0. Okay, so basically this D is constant in this duration. Okay, sometime before rising age, sometime after rising age, you can notice the input D is stable, the input D is constant. Okay, so in this situation you can very easily see that our output will be like this. Okay, so this is the concept of hold time and setup time. Now let me explain, this is called hold time. Okay, so let me explain that. Okay, before, so you can notice whenever this rising edge is coming, because our flip-flop is positive edge triggered, so our flip-flop will be triggered when you get this positive edge. Now you can notice here, okay, before this positive edge, okay, sometime before this positive edge, our input must be applied. Okay, I can say that our input must be stable, our input must be stable sometime before the rising edge. Also, our input must be stable sometime after the rising edge. Now you can notice this time duration, okay, before this rising edge. Okay, so I can say this is the time duration before the rising edge, when the input D must be stable. This time duration before the rising edge is called setup time. So this time is called setup time, and after this rising edge, the input D must be stable. The input D must remain stable for some time. You can notice. Okay, so the input D must remain stable for some time. This is called hold time. Okay, so remember, the definition is very simple. What I am saying is that whenever you have a flip-flop, okay, so you can notice that this is the clock. Let us assume you have a positive edge triggered flip-flop. Let us assume you have a positive edge triggered flip-flop. Now you can notice that because this is positive edge triggered flip-flop, so whenever clock is going from 0 to 1, or I can say this is the rising edge, or I can say this is the positive edge, during this positive edge your flip-flop will be triggered, your flip-flop will be working. Okay, now what I am saying that if you have a clock, okay, so let us assume this is your flip-flop, let's assume this is the D flip-flop. Let me take example, and this is your positive edge triggered flip-flop. This is the Q, okay, Q output, and so this is the input D. Now this is our D flip-flop. Now, what I'm saying is that our D flip-flop is positive edge triggered. So during this rising edge, our flip-flop will work. And let us assume that this is our clock. Okay, let's assume this is our clock. Now, what I'm saying is this is the positive edge, this is the positive edge, this is the positive edge. And let us, so this is the clock. And let us assume you want your output to change. Initially, your output is 0. So let's assume at this point of time, your output is already 0. Okay, and let us assume that you want your output to change from 0 to 1 during this age. Okay, during this rising age, you want your output to change from 0 to 1. This is what you want. Okay, if you want to change your output, this is the output Q. If you want to change your output from 0 to 1 during this rising age, then what I need to do, I need to apply the input. Okay, what I need to do, I need to apply the input D sometime earlier, sometime before this rising edge. So remember, this input D I have to, because I have to make this input D 1. So I have to apply this input D equal to 1 sometime, okay, at least sometime before this rising edge. So before this rising edge, at least sometime before this rising edge, I need to apply D equal to 1. Okay, and also remember, after this rising edge, I have to keep it this D, okay, for some time I have to keep it. So you can notice before this rising edge I have to keep this data steady, and after this rising edge I have to keep this data steady for some time here and for some time here. So you can notice this time duration before the rising edge, this time duration where the input must be steady, where the input must be available, or I can say where the input must be constant, this time duration is called setup time. So this time duration is called setup time. During this setup time, the input must not change. Okay, so you can notice this time duration is the setup time. And you can notice after this positive edge, after this rising edge, again you can notice this input D must remain constant, must be basically this input D must be hold. This input D must be hold for some time. For some time, this input D must be hold constant. So this input D must be constant before this rising edge and after this rising edge. Now you can notice after this rising edge, for how much time, minimum for how much time you must keep this input constant, that is called hold time. That is called hold time. Okay, so this is the definition of setup time. Let me explain. So setup time means basically, okay, you can notice that before the rising edge, I can say, if your you can notice here, if your flip-flop is positive edge triggered, then before the rising edge. If your flip-flop is negative edge triggered, then before the falling edge. Okay, so you can notice before the triggering edge, let me call it triggering edge. Okay, so you can notice before the triggering edge comes, minimum how much, okay, I can say when the triggering edge comes, I can say, okay, so when the triggering edge comes, then before that, okay, like, okay, how before that we need to keep this input steady. Okay, so we need to apply this input, okay, sometime before this triggering edge comes. So I can say when the triggering edge comes, then minimum how much before, I can say earlier minimum how much earlier, okay, our input must be steady. Our input must be available, or I can say must be steady is called setup time, and similarly we can define something called, okay, now similarly we can define something called hold time. So what is the hold time? You can notice, okay, so what is the hold time? Hold time means when the triggering edge comes, then minimum how much time after, I can say minimum how much time after that, okay, minimum how much time later our input, okay, minimum, okay, how much time later our input may change. Okay, so that is basically called hold time, or I can say minimum for how much longer, okay, after this triggering edge comes, I can see here. Okay, so after the triggering edge comes, minimum how much longer our input must be steady, our input must be kept constant, that is called hold time. Okay, so this is the definition of setup time and hold time. So you can notice, let's understand this diagrammatically. Remember, so for positive edge triggered flip-flop, what should happen? Let me explain. So if you have a positive edge triggered flip-flop, if your flip-flop is positive edge triggered, then what should happen? Then it should happen that whenever this positive edge comes, okay, so you can notice this is the clock and this positive edge is coming, you can notice, okay, so this positive edge is coming like this, okay, so this is the positive edge, this is the positive edge. Now I am saying that, okay, like this, so you can notice. Now, so what I'm saying is that this is your positive edge because your flip-flop is positive edge triggered. So for the positive edge triggered flip-flop, what I can say is that this is the triggering edge, okay, and I can say what is the hold time. Hold time means your input, this is the clock, and I'm talking about the input. The input, for example, input means if you are talking about D flip-flop, the input, okay, if you are talking about D flip-flop, then the input is D, then the input is D. And if you are talking about SR flip-flop, then the input is S comma R. And if you are talking about JK flip-flop, then the input will be J comma K. And if you are talking about T flip-flop, then the input will be what? Input will be T. So these are the inputs. Now I am saying that this is the rising edge, this is the positive edge, and this flip-flop is positive edge triggered. So this input must be steady. This input must be steady sometime before this rising edge comes. So remember, at least, okay, how, okay, like for example, okay, it is possible, yes, it is possible, this is possible, this is possible, because you can notice your, so sorry, what I'm saying is this is possible, no problem. So you can notice here the input is stable, okay, the input is stable for a very long time before this edge comes. So before this edge comes, the input is already stable for a very long time. But I am saying that minimum for how much time, minimum for how much time our input must be stable. This is the point, okay. So minimum how, for how much time our input must be stable before this age, for minimum how much time the input must be stable, okay. So during this period the input must not change, and this period is called basically setup time. This is called the setup time, means before this rising edge comes, minimum how, for how much time, just before this, remember, just before this rising edge comes, just before this rising edge comes, minimum, okay, for how much time, okay, minimum for how long our input must be, definitely our input must be steady, that is called setup time. And you can notice that after this, and you can notice after this positive edge, okay, for how long this input must be steady, okay, and this is called hold time. So for how long, okay, minimum for how long our input must remain steady. So this is the point, remember, sometime before and sometime after this positive edge, our input must not change, our input must stay constant, our input must stay steady, our input should not change during this period. Remember, in this period our input must not change, okay, our input can change here, our input can change here, but the input should not change during this period, okay. So this period before the rising edge, this is called setup time, and this period after the rising edge, this is the hold time, because here we are holding the data. Basically after the rising edge we are holding the data for minimum this much amount of time, and here before the rising edge we are setting up the data, this data we are setting up, okay, for minimum this much time, okay. So remember, this is called setup time, this is called hold time, and during this period our data must not change. So when data can change, you can notice the data can change here. So if your age is like this, if your age is here, so you have a positive edge. Now you can notice this is the positive edge. Now I can say that if this is the setup time, let us assume this is the setup time, means at least this much amount of time before the rising edge our data must be stable, our data must be constant, and I can say after this rising edge for at least this much amount of time our data must be stable, our input must be stable, our input must not change, okay. So this duration you can notice, this duration is called setup hold time, okay, this duration is called setup hold duration. And during this duration, remember, during this duration data should not change, the input should not change, okay. During this duration I can say input should not change, should not change. So your input must stay constant, your input must stay as it is, okay. So your input must remain steady during this period, during this period your data must not change, during this period your data should not change, okay. So where your data can change, I can say that your data can change here, I can say, okay, in this period your data can change. So here data may change, no problem. Okay, so here data may change, and I can say that here data may change. Okay, so during this period also data may change. So you can notice this is the complete explanation. This here data may change. And you can notice that this duration, if you notice this duration, this much duration, only this much duration, if you notice, this is called setup time. Because you can notice what is this time before the age comes, before the triggering age comes, before the positive age comes. For at least this much amount of time, for at least this much amount of time, our data must be studied, our data must be set up. Basically we are setting up the data. Okay, and you can notice here this time, if you notice. Okay, so this time, okay, so this amount, this time, you can notice this is called hold time. Because we are saying that after this positive age comes, after this triggering age comes, for at least this much amount of time we are holding the data. For at least this much amount of time we are holding the data. And you can notice here data may change, here data may change, but during this period, setup hold duration, the data must not change. This is the concept of hold time, setup time. I hope this concept is clear to everyone. If anyone has any doubt, you can ask, you can ask your doubts in the comments. Okay, and kindly watch the next lectures, because I am taking a lot of examples I am going to take on this setup time, hold time, and this is a very easy concept. Okay, so we will consider many examples in the next lectures. Okay, thank you everyone.